Materials science, electrochemistry, and building engineering are the key fields of study that contribute to the development and implementation of electronic anodic oxidation (EAO) concept. Materials science plays a role in understanding the properties and behavior of metals, including their susceptibility to corrosion and oxidation. It helps in selecting the appropriate metal for the application and in designing protective oxide layers. Electrochemistry is essential for understanding the principles of anodic polarization, oxidation, and the electrochemical reactions involved in the formation of protective oxide layers. It helps in designing electronic systems capable of applying the required current and potential to induce anodic polarization. Building engineering plays a role in understanding the specific requirements and challenges related to the application of EAO in various settings, such as residential, commercial, and industrial environments. It helps in determining the appropriate placement and coverage of EAO modules, as well as integrating the system into building automation for centralized control and monitoring. Collaboration between these fields facilitates the development of efficient and effective EAO systems that provide long-term protection against rust, corrosion,